so we are starting Unit 7 today. It's pretty short. You can see there are a couple of things for BC that AB doesn't do, but they're pretty easy. One of them we will do tomorrow. So today we're going to start by just kind of talking about differential equations, and then I'm actually going to start with visual representations, which are slope fields and drawing particular solutions, before we talk about actually how to solve the differential equation. On the AB exam, this is always one of their FRQs, which means that it might be one of yours, okay? You probably have heard of differential equations. Like if you have friends in college, they'll say they're taking DiffEq, and that's a differential equations class. It's obviously much more involved and complicated than what we're going to do, but this is a nice overview. I will say this unit tends to be like one of my AB students' favorite units. I think it's like very process based and algebraic in nature, and my students tend to like that. So, all right, so a differential equation in x and y is an equation that involves x, y, and the derivative of y. So basically, differential equation is just a fancy word for a derivative, right? Which we have talked about a lot. So this is just a derivative equation, right? So it could be written as like f prime, f double prime, 2f prime. All of these different things are examples of differential equations. Notice this one is a differential equation of a second derivative in terms of the first and the original equation, right? So they're not always nice and pretty like f prime of x equals 5x squared, okay? They can involve x's and y's or be implicit. We've talked about that as well, okay? So a slope field. So a slope field is a graph of the slopes for a given function at various points. Generally, we will be given a differential equation and asked to do one of two things. One, either sketch a slope field at various indicated points, or two, sketch a solution curve through a given point on a given slope field. So the first two examples we're going to do are this first thing here, sketch a slope field, and then the two on the back, we are going to sketch a solution curve to the differential equation, okay? Slope fields are probably the easiest points you'll get. Don't overthink them. You're literally just showing what would be the slope of the tangent line at each of these points, okay? Some teachers make their students make tables. I do not, okay? Most of my students are pretty good at mental math, and then if you need to write down a table, you can. So I might do a table for a few of these. Now, I will say this particular slope field has a ton of points. However many points they give you, you do need to finish the slope field for all of them, but typically on the AP exam, it's usually about 9 points, not a billion like we have here. I don't even know how many this is. Okay, so I always start like kind of in the middle and work my way out. So for example, what is this point here? 0, 0. And so this is telling us that the slope is always going to be the negative of x divided by 2y. So that would be 0 over 0, which is what?
0.
Undefined. So there is no slope, okay? Some teachers have their students do a vertical line for the slope, undefined slope. Some have them leave it blank. I have them leave it blank, but just know that sometimes it might be visually like up and down as well. But technically the slope is undefined.
And like on the AP exam, would we
leave it blank? Yeah. So basically, anytime that y is 0 on this slope field, we should have no slope, right? It's undefined. So this entire section here, or all 5 of these points, we have no like little tick mark, okay? All right, so let's go up 1 from here. So what's the point right here? 0, 1. What's 0 or negative 0 divided by 2 times 1? 0. And so what we learn is for these 4, because the x is 0, all of those slopes would be 0. Okay, so you can kind of identify patterns, and it makes it go a lot faster. When you're looking to match a differential equation to a slope field, you're going to want to look for those patterns, right? So like if I saw this where all of these, when x equals 0, the slopes are 0, I would be looking for a differential equation that had an x in the top, okay? All right, and then we pick another point. So let's just do this one, 1, 1. So negative 1 over 2, which would be what? Negative 1/2. So you don't have to be exact. If the slope was -1, it would kind of be a 45-degree angle. So -1/2 is just going to be like a little bit more flat than that. But I will tell you, when you're graphing a slope field on the AP exam, they're not going to be like measuring with a protractor, okay? As long as your slopes are positive when they need to be positive and they're negative when they need to be negative, and then they get steeper or less steep in the way that they should, then you're good, okay? So they're going to be looking for blanks, horizontal slopes, and then positives or negatives, and that's pretty much it. They're not like measuring to make sure your -1 slope is a 45 degrees, okay? All right, so what about this one? This is at what point? 2, 1. And so this is why some students like to make a table. So like if you wanted, you could have a table here and you could do like, hey, I'm going to put my xy here, and over here I'm going to put my dy over dx. So then you would do like, okay, at the point 2, 1. So that would be -2/2, which is -1. And so this one is just going to be a little steeper and straight at a 45-degree angle there. You guys see how this works? It's really easy. They're going to give you a differential equation. You're going to plug in the x's and the y's and find the slopes. All right, what's this point here? 1, 2. So whenever I plug that one in, what do I get for the slope? -1/4. So the biggest thing is it's still negative, and it needs to be less steep than this one. So even flatter, okay? And then this one's at 2, 2. And so I've got -2/4, which is -1/2. But more importantly, it needs to be parallel to this one, okay? Now, like I said, mine aren't perfectly parallel. They're not going to be super picky as long as they can tell that you tried to make things steeper or flatter. And more importantly, if the slopes are negative, they all need to be facing the right direction, okay? All right, so you guys go try to do quadrant 2. So you guys go try to do quadrant 2. I'm going to do mine up here, and then you can look up and check it. But try to do it on your own first. If you want to write down the points in the table, that's fine, or you can do it in your head. Okay, when you finish your quadrant 2, you can look up here at mine and kind of make sure yours kind of looks the same. Okay, did yours look like mine? Hopefully, okay. And hopefully you also can kind of see a pattern now, right? So what this is giving us is a visual representation of what's called the solution to the differential equation. So this is a differential equation. It represents the derivatives or all of the slopes of the tangent lines. The solution to a differential equation is the y equals equation that has this as a derivative, right? So this is giving me a picture of what the y equals equation would look like if this was its derivative. Okay, that's what it's giving us a visual representation of. And then eventually when we solve the differential equation, we will separate the variables and actually find what the y equals equation would be that would satisfy this. Okay, so this is a picture of what's called the general solution. Okay. All right, so now let's just look at quadrant 3. So right here, this is -1, -1. So what do you notice here? That slope is what? It's negative what? -1/2. So it should look similar to what? Quadrant 1, right? In fact, is anything going to be different? No, right? So we can kind of look for the pattern there and then kind of identify or recognize that pattern. And so once you can kind of start noticing patterns, it does make filling in these slope fields faster, right? So what would we know about quadrant 4 then? It should mirror what? Quadrant 2, right? So then we're going to have here, here, back to here, and a little bit flatter. Now, like I said, this almost kind of looks like a circle, but remember, we actually had undefined slopes here. Do not draw that dotted line. I'm drawing that there to let you know that like one of my solutions might be up here or one might be down here. Now, how could I have multiple solutions? Well, remember when we integrate, we always had to put a what? Plus C, right? And then depending on what that plus C is, that changes the solution to the equation, right? If there's a plus 5, that's very different than the solution that has a minus 7, right? So a general solution to a differential equation has the plus C. It's like these are all of the possible y equals that would have had this as a derivative. And then a particular solution is the y equals that also goes through a specific point. And they gave us that point which would help us solve for C. Okay, so this is a picture of the general solution. And then if I gave you a point on the graph, which we're going to do on the back, we could give a sketch to the solution curve of the particular solution, okay, through a given point, right? So then they would have to give us a point. All right, let's do one more slope field because they do vary. You just have to look for patterns. The biggest thing is like I said, usually on the AP exam, it's going to be a little bit more like this, maybe 9 or 12 points max probably. And so you're literally getting points because you can plug in numbers. Okay, and I guess you know what a slope looks like, okay? So these are probably the easiest points you can get on the AP exam other than also average rate of change, right? Slope formula or plugging in numbers, those are pretty easy points, okay? All right, so consider the differential equation. This on the axis provided, sketch the slope field. Now notice they did not give me any points at what? X equals 1, and why is that? They would be what? They would be undefined. So you would leave those blank, but on top of that, sometimes they just don't even put the points there. And you only have to draw the slope field for the points that are drawn. Okay, so in this case, it looks like we have 10 points that we have to do. Okay, all right, so the first thing is, let's look for patterns. If y equals 0, what does that mean? The slope is 0. So I can go ahead and draw this. Now, the one thing I want to tell you is you want to make sure that they can tell that you have horizontal lines drawn there, but also the flip side of that is if they give you a slope field, because there will be a few on multiple choice sometimes where they give you a slope field and you're supposed to match the differential equation, they will not make sure that you can see it. So it might look like there's no tick marks on the x-axis, and you can't assume that they are there or are not there. You have to look at the other ones to figure out the answer from there. They won't like make it extra bold there. So that's kind of unfortunate, but that's because that's what it would do on the calculator. Okay, so 0, 1. What is the slope at 0, 1? -1. So we just make sure we're at as close to a 45-degree angle as we can get. What about 0, 2? -4. So does that get steeper or flatter? Way steeper, right? So it's still negative and it's steeper. That's the main thing they're going to be looking at. Let's go here, 0, -1. Try again. -1. So back to that 45-degree angle. What about 0, -2? -4. So these mirror each other, right? Because the y is squared, it doesn't matter if the y's are positive or negative. So what does that mean over here? These points will mirror as well, right? Because the y is squared, it doesn't matter if the y is 1 or -1, those slopes will be the same. So that allows us to move through this slope field a little bit faster as well. So 2, 1. So at 2, 1, what is my slope? 1. And that means this slope would be 1 also, because we just said that these should be symmetrical since it doesn't matter if the y is positive or negative, and these two would have the same x value. And then what about 2, 2? 4. So way steeper, and then that means down here would be way steeper. Once again, guys, this is a representation of the general solution, and then if I wanted to graph the particular solution, they would give me a point on the solution to the differential equation. I could graph the point and then try to follow or mimic the slope curve as best as I could. Okay? All right, turn the page. So this is what I'm talking about with sketching slope curves. So a portion of the slope field of the differential equation is dy over dx equals cosine y. Notice this is an implicit differential equation, so this is the derivative equation. And it says is below, sketch the solution curves through the points 2, 3, and 0, 0. So it's two different solution curves. So I'll do one in blue, and then I'll do one in pink. Because remember, this is a picture of the general solution, but if I want a particular solution through one point, that's one particular curve. So the very first thing you need to do is put your point on 2, 3. Notice it is counting by, it looks like thirds, kind of. So make sure you do go to 2, 3. I'm blind, so hang on, I got to pick it up closer to my face. So it looks like 2, 3 is here, and then here. Okay, so that's the particular point that they're giving me. And then, do you notice these horizontal slopes right here? That typically is going to represent a horizontal tangent line on your particular solution. And there's one up here as well. And then all you're going to do is follow the slopes from that point. So right here, the slopes kind of come down and then eventually approach that horizontal tangent line. And then if I come this way, I follow the slopes here. And then once again, it appears that there is a horizontal tangent line that way. Okay, now I know that seems way too easy and you're like, what? But that literally is how you do it. There were a few questions on Delta Math where you could draw these, but like I said, because my cursor, like my hand's not very steady, maybe if I had an Apple Pencil it would be better, but like my curve was too curvy basically, or they would be like, oh, you went too vertical and it didn't pass the vertical line test. It was really annoying. And then when it would show me my solution, mine would look like almost the exact same. So I took those off of your assignment, but just know this is how you would do it. Remember, your test booklet will be still written, so if you do have to draw a solution curve, you will be drawing it by hand, and so this is how you would do it. Okay, all right, so for the other one, we put our point at 0, 0, but notice these slopes go a little different. So to come this way, we follow these slope fields and then stop at that horizontal tangent line, it looks like. And then we follow these slopes this way. And guys, notice the reason I'm following the slopes is because these are the slopes of the tangent lines at each of those points on the solution curve. What do you think? Pretty easy? Pretty easy. Okay. All right. And then same thing here. So 0, 2, so we'll find 0, 2 first, which is right here. And then we essentially just follow the slopes. And obviously this is not an exact science, and so when you're doing this on the AP exam, they will be looking to make sure that you plotted the point for the particular solution, and then they'll be looking to make sure that you followed the slope curve. They don't get real picky, so you just have to make sure you're on track. This is -3, -2.
It's just 3, -2.
Oh, JK, 3, -2, thank you. 3, is it here? There you So then once again, I'm just going to follow these slopes as best as I can. And notice, this is not a function, right? The green one I just drew. But remember, whenever I have this, this is an implicit differential equation, so I might not be able to solve it just for y equals, right? My equation might be implicit as well as my differential equation. So for example, a circle is not a function, but a circle can have a differential equation if I do it implicitly, right? Which is what it looks like probably happened here. All right, last but not least, this just says consider the differential equation. This describe all points in the xy plane for which the slopes are positive. So when you get a question like this, which often, okay, a lot of differential equation questions, part A will be a slope field or sketching the slope curve. Part B will be something like this, like some kind of a conceptual thing. And usually those two parts together account for like 3 of the 9 points. The other 5 or 6 points are usually the solving process, which is what we're doing in a few days, okay? So consider the differential equation, describe all the points in the xy plane for which the slopes are positive. So first and foremost, I encourage you to look at one variable at a time. So for example, if I'm looking at the x's, does that impact whether the slope is positive at all? No, right? Because if x is positive, it'll be positive. If x is negative, it could still be positive, right? So the only thing that's going to impact whether the slope is positive or not is the y value. And what must be true about y for the slopes to be positive?
Greater than 1.
So you would just say y is greater than 1. And that's it. You don't need to write a big dissertation, okay? Sometimes it will be dependent on the x as well. So you would say the x needs to be this and the y needs to be this, okay? But in this case, it's solely dependent on the y. As long as the y is greater than 1, the slopes are going to be positive, and that would answer the question. Cool?